Welcome back, everybody. We're going to get Chapter 6 going today, talking about something called the Law of Sines. Two parts of this lesson. We're going to do part 1 today. We're going to cover the bulk of the lesson today, and then we'll save the one tricky part for this section for part 2. Okay, but we'll show you what the Law of Sines is and how it works today here. Alright, so what is the Law of Sines? Here it is. We're going to say for any triangle ABC, and I have just a random general triangle here, triangle A, B, C we could say. Law of Sines says that the sine of big A, so as in the sine of angle A, divided by little a, side length A, the length across from angle A, is equal to the sine of angle B divided by side length B, which is equal to the sine of angle C divided by the side length C. Okay, so what I have here is a relationship between the angles and sides of a triangle that I can use to solve for both angles and sides. We'll show you how to do that in a few minutes. And the big thing here is this for any triangle ABC. So far in class, we've solved for sides of triangles, but they've always been right triangles. Okay, the law of sines is going to allow us to stick with one of the big themes of this class, okay, taking our right triangle trigonometry and expanding it beyond the right triangles. This law is going to work for any triangle, whether it's a right or not. All right, now first thing I want to do with this is prove the law of sines for you quick. Okay, so you don't need to copy this down. You don't need to be able to do this, obviously, but I want to show you where this is coming from. So let's say I have a non-right triangle, so any triangle. What I'm going to do is I'm going to split it in half using an altitude. I'm going to call it the height, another name for the altitude of a triangle. And what that's going to make is two right triangles, one on the left, one on the right. Let's set up some trig between those. So if I'm looking at angle A, I can say that the sine of A is equal to opposite H over hypotenuse B. And on the right side, I can do the same thing. I could say that the sine of B is equal to opposite H over hypotenuse little a. And I'm using sine, hence the law of sines here. What I'm going to do is I'm going to solve both these equations for H. On the first equation, I'm going to multiply both sides by B. And that leaves me with B times sine of A is equal to H. And same idea for the second equation. I'm going to multiply both sides by A. Cancel my fraction. That leaves me with A times sine of B is equal to H. Okay, now since I have two equations that are both equal to H, what I can do is I can set them equal to each other. Since they both equal that same height, I know that B times sine A is equal to A times sine B. Okay, so it's starting to look like what we have up top here, and then as a last step, what I can do is I can divide both sides of this equation by both B and A. And that's going to cancel out the B's on the left, so there's my sine A over A. That's going to cancel the A's on the right, so there's my sine B over B. All right, so that's where that formula up top's coming from. Now we can do the same thing. We can make a second height to kind of bring the C into the equation. But, okay, like we said, this is an extension of what we've done with our right triangles, of right triangle trigonometry. All right, so we don't need to be able to prove the law of sines, but we do need to be able to use it. Let's show you how. Okay, problem 1 says solve triangle ABC given angle A is 36, B is 48 degrees, and side A is 8. Now, when I say solve a triangle, that's something we've done already this semester before, okay, just with right triangles. Solving a triangle means we'll give you some of the parts. You need to figure out what all the other parts are. In other words, what are the other angles and side lengths? Okay, this is going to be a lot easier with a picture. Okay, I'm not going to give you one, but we can just draw a general triangle. Let's say I have triangle A, B, C. And this will work just as well if we flip the A and B or the C around. Okay, but if you draw it the same every time, it's going to make life easier. And let's label what we know here. We know that angle A is 36 degrees. We know angle B is 48 degrees. And little a, so the side length across from A, is 8. We don't know little c, and we don't know little b. Okay, so we're going to use the law of sines. Let me write it out here quick, and we'll show you how this is going to work. We know that the sine of angle A over side A is equal to the sine of big B over little b, which is equal to the sine of big C over little c. And let's do this. Let's fill in what we know. I take that back. Let's do something else first. I'm going to say I can find angle C without any trigonometry involved. Okay, I can get that right off the bat here. Anytime you know two angles of a triangle, you can always find the third by subtracting from 180. So I can say that angle C is equal to 180 minus 36 minus 48. Okay, because the three angles of a triangle always add to 180. Okay, when I do that, I end up with a 96 degrees. So I suppose we can fill that in right off the bat. Okay, and then it comes time for the law of sines. Let's fill in what we know to this equation here. So I know angle A is 36 degrees. All right, I know little a is 8. I know angle B is 48. And I didn't know right off the bat, but we just solved for it. I know that big C is 96 degrees. Okay, what I have here is an equation that I can solve for missing parts in. And the trick is going to be I want to pick 2 out of these 3 fractions to work with. And I want to pick 2 so that I only have 1 variable in it. So for example, I would want to set up to solve sine of 48 over b is equal to sine of 96 over c. That equation has 2 variables. I couldn't solve for either b or c. What I'm going to do is I'm going to use the a part, and I could go for either b or c with it. We'll go with the b's first. I'm going to set up this equation here, because then what I can do is I can get the b by itself and solve for b. Okay, so let's set that up here. Let's say I have sine of 36 over 8 is equal to sine 48 over little b. All right, I want to get little b by itself, so what I'm going to do first is I'm going to cross multiply and then divide. So cross multiply, and that's going to give me b times sine 36. And that's our general way for solving a proportion, is cross multiply and divide. We'll multiply 8 by the sine 48. And then to get b by itself, we'll divide both sides. I'll divide both sides by this sine 36. And that's going to give me that b is equal to this ugly expression here, 8 times sine 48 divided by sine 36. Okay, and once we get the b by itself, we'll plug that into our calculator. I'm not going to pull mine up here, just a couple of things about it. I lied, I'm going to pull my calculator up. All right, we'll pull it up, we'll walk you through one of these. Okay, so first off, let's make sure we're in degree mode. So mode, yep, I'm in degree mode, so we're measuring angles in degrees. And then as far as plugging this in, it's pretty much the way you see it. We'll go 8 sine 48. The only really thing is to make sure you close off your parentheses for your different signs. And then divided by sine 36. Hit enter. End up with a 10.115, we could say. Okay, for this unit, let's get in the habit of rounding to 3 decimal places, just because it's going to make life easier and it's going to make our answers more accurate as we start using answers we find for other answers. All right, so we end up with a 10.115, we could say. Okay, so that's how we use the law of sines. Now I still want to find, so I've got B, we just said is 10.115. I still want to figure out what this C is equal to, so I can do the same thing. Now at this point, since I know my B, I could set up sine B over B equals C over C. But I want to avoid that because we're rounding this B, so that's going to throw my answer off a little bit. Also, if I made a mistake with the B, as long as I don't use it to find C, I could still find C correctly. Okay, so for this one, we'll do a different color here. I'm going to go with the A over A equals C over C. So I'm going to set up that sine of 36 over 8. Once again, I'm going to use that same proportion. Is equal to sine of 96 over C. Then once again, we'll cross multiply. So that's going to give me a C sine 36 is equal to the other cross product, 8 sine 96. And once again, I'll divide both sides by the sine 36 to get the C by itself. So we have C equals 8 sine 96 over sine 36. When I plug that in my calculator, I get a 13.536. All right, we'll say those are my three missing parts. Okay, we've solved for using the law of sines. Okay, so the triangle is solved now. All right, part B is, I'm sorry, not part B, but problem 2 is actually the same idea. Now the triangles we set up a little bit different, but part of the process here is the problem solving piece, deciding which part can I find first, which steps do I need to do first, what can I do next. Okay, so why don't you give problem 2 a shot, use the law of sines once again, and if you get stuck or to check your answer, hit play and we'll run through it for you. All right, let's go through problem 2 here. I'm given some sides and angles. So once again, I'm going to draw a just random triangle. And I'm going to label it consistently just to make life easier as I go through more and more of these next couple of days. Okay, I'm given B is 62 degrees. I'm given angle C is 30 degrees. And I'm given little a is equal to 10. Okay, now as far as where do I start with this one, let's plug in what we have. We could say that sine of A, which we don't know, over 10 is equal to sine of B, which is 62, over little b, which we don't know, which is equal to sine of 30 for the C over little c, which we don't know. Okay, now what you notice with this one is right off the bat, I don't have any fraction that's filled in all the way. Okay, so I can't use the law of sines yet. What I actually have to do first with this one is figure out what angle A is. Once again, we can just subtract from 180. We can say that angle A is equal to 180 minus 30 minus 62, which gives us an 88 degrees. Okay, so now I've got that A filled in, and once again I can use the A to solve for the B and then to solve this for the C. Okay, it's just coincidence we're using A twice in a row this time. It could be, you'll see ones where we start with different ones. Okay, so go through that process again quick. We can say that sine of 88 over 10 is equal to sine 62 over little b. Okay, cross multiply, we get b sine 88 is equal to 10 sine 62. Then divide, they'll give us b is equal to 10 sine 62 over sine 88. When I plug that in my calculator, I get 8.835, we could say. We'll do the same thing with the c, and again I'm going to use the a's because I know those are exact. Okay, we can say sine 88 over 10 is equal to sine 62 over b. Okay, cross multiply. I'm going to divide in one step here. I lied. Let's make my eraser bigger. Come on. All right, whoops, I lied. So I want sine 88 over 10 is equal to sine 30 over c. Okay, because I want to solve for c here. I'm going to cross multiply and divide in one step. I'm going to say I can tell this is c is equal to 10 sine 30. All right, and I know I'm going to be dividing by the sine 88. Sine 88. Okay, as you do more of these, as you practice more, you're going to see a lot of shortcuts. Okay, I'm taking one there. And I know that's going to round to 5.003, we could say, if we round that to 3 decimal places. Okay, so same idea, a little bit different setup on our triangle. We had to solve for that a first. Otherwise, that's kind of the basic way to use the law of sines to solve for sides and angles. All right, let's show you a slightly different way these things can work out in problem 3. So again, solve triangle ABC given a few parts of that triangle. Now just looking at the numbers you're given, you're not going to necessarily know what the triangle is going to look like. We'll talk more about that in the next lesson. But let's draw this out once again. Okay, we've got ABC, and I know that B is 26 degrees. Little a is 6, and little b is a 7. Okay, if I fill in my law of sines, we have sine of big A over 6 is equal to sine of big B, which is 26, over 7, which is equal to sine of big C, which we don't know, over little c, which we don't know either. Okay, so it looks like I can use the a and b. This time I know all the b's. We'll use that to solve for a. And notice in this case my variable is the angle. Okay, it's not a side length, it's an angle. So let's show you how to solve for that here. We'll set it up the same way. We'll say we have sine of angle A over 6 is equal to sine of 26 over 7. Okay, now here I'm not going to cross multiply and divide all the way. I'm just going to multiply both sides of this equation by 6. Okay, because right off the bat, that's going to get the sine A by itself. So we can say sine A is equal to 6 sine 26 over 7. Now, if you did take both cross products and multiply by the 7, you just divide that out. Okay, so my goal is to get the a by itself, so we'll start by getting the sine A by itself. And now, if I'm looking for an angle, what I need to do is I need to get the angle out of the sine function. I need to undo the sine function. The trick for that is I'm going to take the sine inverse of both sides of my equation. Okay, because the sine inverse and the sine are opposites of one another. They'll cancel each other out. So that's going to leave me with a is equal to the sine inverse of the fraction I just had, the 6 sine 26 over 7. Okay, and we'll plug that in. I'll pull my calculator up here quick. A little off. There we go. And for that, we'll just say second sine inverse 6 sine 26. Making sure I close my parentheses as I go. Divided by 7, close parenthesis. Okay, so basically the way you see it, we'll hit enter, and we get a 22.070, I suppose. All right, for angle A. Okay, once I have my A, I'm basically back to where I was before. To solve for the C's, I can get the angle right off the bat. I can say that angle C is equal to 180 minus the 26 and minus the 22.07 we just found. All right, so in other words, a 131.930 We'll say we're rounding to 3 decimal places here still. As we're running out of room here. And then once I have that c, I can use my b's once again to solve for the c now. So I can set up sine of 26 over 7 is equal to sine of 131.93, all right, over the little c we're looking for. Okay, cross multiply, divide, that's going to leave us with c is equal to 7 sine 131.93 over the sine 26. Okay, I'm going a little quicker here just because we've done a bunch of these now. And we can say c then is equal to 11.87, and scratch that. So I want to round it up. We'll say it's equal to 880, rounding to 3 decimal places. All right, so there's my other 2 parts there. All right, so part B is the same idea. You're going to use the inverse once again. Why don't you take a minute, pause the video, run through that one, then hit play to check your answer, make sure you're doing it right. All right, so let's run through part B here. Let's draw our triangle up. Let's label what we know. We've got angle B is 49 degrees. We know little b is 13 and little c is 11. Okay, what can I solve here for? We've got sine of a over a. We don't know either of those. We know both of b's though. So I can say sine of 49 over 13 is equal to sine of the big C I don't know over little c 11. Okay, as far as what equation can I set up that actually gives me a single variable, we're going to be using the b to solve for the c this time. And the first thing we solve for is that angle c. So let's set that up. We can say that sine of 49 over 13 is equal to sine of big C over 11. Okay, I want to get that sine of C by itself first, so I'm going to multiply both sides of this equation by 11. That gives us an 11 sine 49 over 13 is equal to sine of C. Okay, and then we're going to take the inverse on both sides. I'm not actually going to write out that step. I'm going to say that I know that C is equal to the sine inverse of this fraction. Okay, so you don't actually need to show things canceling out here. We can just say we know it's equal to the sine inverse. Okay, and plugging that in, I end up with a 39.688, we could say, when I round that to 3 decimal places. Oops, that's up here. Okay, once I have that, I know both my angles. Now I can solve for angle A by subtracting from 180. And you'll notice here that stuff's going to happen in different orders every time. It's part of the problem solving. Okay, so I go 180 minus the 49 minus the 39.688. We end up with a 91.312. And now I can use the big A to solve for the little a. We could say that sine of 49 over 13, once again, is equal to sine of 91.312 over little a. Okay, cross multiply, divide, that's going to leave you with a is equal to 13 sine of 91.312, okay, divided by sine 49. And we end up with little a is equal to a 17.221, we could say. All right, so there's my 3 missing parts. All right, there you go. There's part 1. For the homework, let's say start off with 1 through 3. 1, 2, and 3. Okay, these do take a little while, so I'm not going to throw too many at you, but give those a shot. Make sure you're okay with kind of the basic part with this first, and then we'll get into the one tricky piece of it tomorrow. Okay, go to town on the homework, get 1 through 3 done, and like usual, if you need some help, make sure you're reaching out for help.